Grab your notepad, rookie. We're skipping the fluff today. Put down the wrench and step away from the toolbox. You're out here on the hangar floor now. And before I let you touch a multi-million-dollar piece of machinery, you need to understand the language it speaks. And that language? Well, it's written in the manuals, the standards, and the drawings. This is your Module 7.5 B1 Test Prep Explainer, and we are going straight into the specific questions you actually need to know to survive out here. So pay attention.
Okay, let's dive into this. Listen up, because this is literally the single most important lesson you're going to learn from me. You are only as good as your ability to read the paperwork. I've seen way too many green apprentices think being mechanic is just all about turning bolts. It's really not. If you don't know exactly what you're installing, how it's certified, or where it belongs on this specific airframe, you are a liability. We master the paper trail first, and that means nailing the reasoning behind every technical choice on your exam.
Section 1. The Blueprint Table and Engineering Drawings.
Reading these engineering drawings isn't just some academic exercise, It's your foundational skill. Take question 11 on your test, for example. The very first place your eye should go on any drawing is the title block. Why is that the correct answer? Because it contains the essential information required for the identification, administration, and distribution within our maintenance organization. It's absolutely crucial because it stops catastrophic mix-ups. And for question 23 regarding repair drawing numbers, pay close attention here, because generally that drawing number maps directly to the part number. You get the drawing number wrong, you're going to order the wrong part, and the plane doesn't fly. Simple as that.
Now, questions 34, 80, and 89 are going to test you on different drawing types. You have to pick the right tool for the job. Say you need to see the internal guts of a component to answer question 34, you look at a sectional view, which literally gives you a complete section right through the part. Makes sense, right? Now, if you're tackling question 80 and trying to figure out which of 10 identical-looking brackets is the right one, you need a collective drawing. That shows parts of essentially similar shape, but of different dimensions. And for question 89, putting a whole landing gear strut together, you want a combined drawing, because that shows the complete assembly, including all individual parts right there on a single drawing.
When you're actually reading the finer details of these orthographic projections, specifically for question 118, you gotta remember our viewing angle. You're always going to be looking at third-angle American projections. And when you're hunting for specific identification markings on those parts, well, don't go looking for paragraphs of text. The drawings use symbols or code letters to indicate both the position of the markings and the method of application. It's kind of like a shorthand that you just have to memorize to get these answers right.
Section 2. Schematics versus wiring diagrams.
All right, step away from the structural blueprints for a second. Structures are great, but modern aircraft are basically flying computers. Now, what's really interesting about this slide is exactly why a mechanic chooses one over the other. For questions 126 and 133, you really need to understand the clear distinction between how we troubleshoot versus how we actually repair. If you're trying to understand the broad flow of the aircraft, say, figuring out how the hydraulic, pneumatic, or electrical systems interact, you grab the schematic diagrams. But once you've found the broken wire, the schematic is totally useless. You switch over to the electrical wiring diagrams. These specify the exact granular details you need to make the fix, like the gauge of the wires, specific types of terminals, and component part numbers. Schematics to troubleshoot, wiring diagrams to repair. Remember that.
Section 3. The alphabet soup of aviation standards.
Follow me over to the hardware bins. Just look at all these bolts, nuts, and washers. How do you actually know a piece of hardware is certified to fly on a commercial jet? Well, questions 137 and 156 are going to hammer you on this exact thing. ISO stands for the International Organization for Standardization. It's a worldwide entity and basically the largest developer of standards. If you see AN, that's Air Force and Navy, meaning it was developed by the military. And NAS means National Aerospace Standard. Knowing why a part standard matters is exactly how you ace question 156. It tells you its heritage, its exact manufacturing tolerance, and most importantly, whether it legally belongs on the aircraft in the first place.
Section 4. Navigating the ATA 100 library.
Let's head over into the technical library. Imagine if every single manufacturer formatted their manuals differently. You'd literally have to relearn your entire job every single time you switched from a Boeing to an Airbus. Nightmare, right? To answer questions 161 and 175 correctly, you must know about ATA Specification 100. It is the universally established standard for the presentation and structure of technical data across all commercial aircraft documentation. And for question 176, remember why this actually matters. It provides a common referencing standard so everyone, everywhere, speaks the exact same language. So the crucial point here for knocking out questions 190 and 209 is knowing exactly how this ATA 100 system is broken down into a 3-element identifier number. The first element identifies the main chapter, but pay close attention to that second element because that is the correct answer for identifying the subsystems as sections. Then the third element drills all the way down to the specific subject. You basically use this to navigate the entire aircraft.
Let's test you right now, rookie. Question 222 directly asks about this. You're assigned to work on the engines today. Without looking it up, what system chapter of propulsion are you pulling from the ATA 100 library? Take a guess.
It's Chapter 71. System 71-XX-X is propulsion. That is the correct technical choice for questions 222 and 224 because engine data is universally standardized right there. If you're out there fumbling around in the 20s or 50s looking for engine data, you're just wasting precious time on the hangar floor. Commit these core chapters to memory. It's going to save you so much hassle.
Now, let's look at questions 231, 248, and 257. Once you've used your ATA 100 chapter to find your specific system and you've found the broken component, which manual do you grab to actually order a replacement? You grab the Illustrated Part Catalog, or the IPC. It is a core manual within the ATA 100 specifications, and knowing it's specifically used for identifying the physical parts to give to the stockroom is exactly how you confidently pass those test questions.
Section 5. Effectivity and Legacy Tech.
All right, here's where I see rookies make their absolute biggest mistake, and it's exactly what questions 271 and 297 are trying to trick you on, the effectivity code. Look, just because a part is listed in the IPC chapter you're looking at does not mean it applies to the specific tail number sitting right in front of us in the hangar. Airlines order different configurations all the time. The effectivity code tells you the applicability of data specific to an aircraft's subtype. If you ignore it, you install the wrong part and you literally ground a flight. That is exactly why it's the correct answer on your exam. Don't fall for that trap.
You kids have it so easy today with your digital iPads and perfectly searchable ATAP PDFs. But for questions 320 and 347, you need to understand legacy tech like microfilm. Back in the day, older publications would be reproduced on a roll of film shoved in a cartridge, and you'd have to use a projector to literally wind the film through a gate just to display a single page on a screen. Trying to read tiny code letters on scratch microfilm at 2 a.m. builds character, let me tell you.
So, I'll leave you with this little thought to chew on. Are you actually trusting the standard, or are you just out here turning the wrench blindly? Everything we do is dictated by a drawing, a standard, like ISO, or an ATA chapter. If you don't know why a document dictates a specific repair, you just aren't ready to make it. Keep reviewing the reasoning behind these technical choices, especially as you finish up with question 362. Master the paperwork first, rookie. The wrenches can wait until tomorrow.